Okay, let's get started. Thanks to Joachim, now we want to throw away all our REST APIs and doing GraphQL, but this time we definitely make sure that we're going to make it right. So we want to build APIs that last for decades, and one methodology to make sure that we build APIs that last is to use test-driven development. Test-driven development is around for a while, since 2003, and it evolved a lot, and therefore nowadays we can use test-driven development even for APIs in a microservice environment. Sorry, I'm a little bit sick. Yeah, at Cybers we also do a lot of microservices, and we build our whole platform on the whole middleware on microservices, and this talks about our strategy, how we do testing. Therefore, I should mention that we use dynamic languages. We primarily, our services are written in Node.js, so maybe some of the testing we do might sound weird to you, but it makes sense to us. So you probably might have to adjust this if you do Java or stuff like that. But don't do it, do Node.js. I would like to give you a short introduction of what we're doing, because our challenge would make more sense to you, which we're facing, and also the examples I would like to show you. So what we are doing, that's what we are doing. We map industrial protocols. We provide access to industrial devices so that it's way easier to access them. We map these devices to a REST API or to MQTT, and this enables manufacturers of industrial devices to provide services for these devices, like predictive maintenance or monitoring, and make sure that everyone just get the data he should. So we provide access control based on data point level. And this is powered by microservice architecture. And this brings us to our challenges. We are in an industry sector, so we have to make sure that everything is running, everything is doing great, and if it's not, we have a problem, because we do this as a service. We provide data as a service, and if our solution is not working well, we have a problem, because we take full responsibility for service level agreements. Therefore, we have to make sure that everything is tested 100% and working fine. But that's honestly not the reason why we wrote up our whole test strategy. That was totally a different reason, because we are still piloting, and we want to make sure that we turn our customer needs into a great product. So we were facing the situation that we got a lot of feedback from our clients, and we want to make sure that we really represent the exact feature in our code base with our tests. So that's why we wrote up our strategy. Besides that, as most of you, we have loosely coupled microservices, but honestly, we have heard a lot of talks about OAuth. What should we do if the OAuth server is down? So they are kind of highly connected. They kind of depend on each other. And we have to find solutions what we're going to do if the OAuth server is not available. So we have to test failover scenarios. And we are a startup. So we have a development team of 3 people. So we have to be efficient. So we shouldn't waste too much time with writing tests, but tests are still important, so we have to find a way to do efficient TDD with limited resources. That brings us to one question. I like to quote it a lot, because the guy who said it, he wrote one of the first blog posts on testing development for APIs, Steve Klobnik. We have to answer the question how we validate that our API is working as intended. But if we look at a single API, that's still true, and we still have to answer this question, but that's not enough anymore. Nowadays, we have to answer this question as well. I modified a little bit and re-quoted somehow. So we have to do this in an efficient way, and we have to look at the whole ecosystem. Let's look at the ecosystem. That's a pretty simplified, inspired by our application. So we have 3 services. They all talk to each other, non-isolated service, and yeah, if we have these kind of services, where should we test? Where should we start? So should we look at the one service or another service? So what we do, we look at a story. You all know stories. You're probably all familiar with Agile somehow. So what we do in the first place, we ask ourselves, what is really the feature we want to implement, what is our role, and what is that we want and why we want it. That brings us to stories like this, for example, a story for reading an access-controlled device. So this is kind of the start where we try to connect the business with our development team and to make it more easier to make sure that the needs from our customers are really take place in our development and really reach our product. So what we do is that we turn each scenario, each story into one scenario per service. So these not per service. So we would have, like in Gherkin, a scenario where we have different services given and some events that occurs, and then we do something. So this is kind of the representation of a story, and we have different scenarios per different use cases. We should at least have two, a good case and an error case. Otherwise, we probably just test the good side, and there's always a bad side, to be honest. So that's where we start off when we think of tests. You know this picture? If you look back at our tests, there was a test where we want to get data from an external device. So let's put an external device, and that's what we want to test. But honestly, we don't like to talk to external devices because that's hard to test. So what we do in a microservice environment ecosystem as well, we stop external stuff we are not able to control. And we turn these kind of scenarios into acceptance tests. These are parts of our acceptance tests. We split up acceptance tests and platform tests on the one hand, where we implement scenarios which test kind of the whole platform, where we want to verify that our platform really works, and we test to all microservices which are involved in these kind of scenarios. This is more black box testing, where we really look at all our microservices as a black box, so we just stop external devices which are out of our control. We have two different types of platform tests. We also do graphical interface platform tests. We're not just doing the cool stuff. We also look at weird looking interfaces and do some clicking and simulate that and spawn a request somehow. That's also part of our acceptance test, because we are dealing with APIs a lot, but the one who's also administrate our application somehow supposed to be a real person. And if the end is not really working well and the beginning is not working well, then he's probably not really satisfied with our solution. But that's not enough for acceptance tests. Part of our acceptance are also contract tests. So what we also test is that we test the interface of one service. So we want to verify that we saw some JSON schemas to specify services. So what we do is that we really test that the interface of our service does not change. And if it changed, then we probably made a coding error, or we coded first and did not do test development. So that's testing of our whole platform. But we should dig deeper. We should look at a single service, as we did in the beginning before we were talking about all this microservice stuff. And maybe the terminology I use for my tests are not the one you're comfortable with, but that's the terms which has been established in our company. So next step for us is integration tests. They are also known as component tests. That's the term Martin Fowler is using. O'Reilly calls them service tests, also a great term. It has historical reasons why we call them integration tests, but it fits for us. And what we do with integration tests, we look at a scenario and we turn this scenario into a test for a specific service. So what we do when we look back at the test case with the all server and with the device service, we mock in one test case the all service and just testing the device service, and the other way around as well. So we have one test case per service for each story. So this is kind of the service-specific testing. And it's kind of end-to-end testing, and it's kind of black box testing, but it's the end of the service and not the end of our ecosystem. We have a microservice universe, so there's way more, and that's the reason why we introduced the term gray box testing. It's kind of a mixture. We look at our microservice as a black box, but we know how our ecosystem, so we know what's going on in our ecosystem, and we are able to stop and to mock the other services. So that's the reason why we came to this term, because the other thing is really present to us and we are able to mock them. That's a microservice, and that's what we're going to test. But as I said, we don't want to talk to external stuff, also if it's our reach. In this case, we prefer to stop it, because then we have control. And we insert a test client so that we can send some test requests, and we are happy we have a test case. That's probably not enough. We have to dig deeper. Especially in Node.js, we dig pretty deep, and what we do is that we test the communication between some modules, between some classes. We want to verify that they behave in the correct way, that they interact in the correct way. So this is the way where we do white box testing, where we just focus on the communication between these two and mock everything around and make sure that these two components, they work nicely together. That might be if we have a look at this part of a domain of a microservice, for example, the controller and the device handler. We want to make sure that they communicate correctly. So we stop a protocol, for example, and we just focus on these two, that they work nicely together. That's not enough. We have to go even deeper, even inside the module. So you're all familiar with unit tests, and that's what we are still doing. You can't skip them. They are really essential, because we are focused on one service, we are focused on functionality of one service, and we have to verify that this is working. So what we do is that we mock everything else. We don't care about the surroundings. We're just concentrating on this small unit, and we do white box testing where we focus, for example, at the device handler and stop the rest of the world and don't care about it, so that we can make sure that our tests will running smoothly. That's a lot about test types, but how to do test-driven development here? Well, as you probably already guessed, we start with acceptance tests, we start with a black box. So we start with scenarios. Per story, we should at least have 2 scenarios, but we do the loop first with 1 scenario where we have the black box, our microservice ecosystem. So we implement with Gherkin first these kind of tests. It's a bit tricky to do that when you really start off, because nowadays it's pretty easy to us. We have huge test libraries, and we kind of have implemented all these things. So it's kind of a long process. So what we do when we start off in a story, you find kind of a raw definition of a scenario, which should be written by someone outside of the dev team. So it's in general our product owner who does that. He should really think, okay, what I want to have, and then we have to match that with our Gherkin stuff we have and make sure that we able to implement this test case. Afterwards, we go to the integration test, where we, in this gray area where we're not quite sure if we really do black box or white box testing. And we do an integration test for each service where we mock the other services which are not required right now. Afterwards, we do unit tests. That has historical reasons. We decided to do unit tests and to focus on the functionality, because it felt weird to us to do functional tests and to focus on the mid-level, on the interaction, and to test something which was really hard to grab. So we decided, okay, now we know the big picture. We defined how the services should interact. We defined the interface of the service, and now we want to really implement the functionality of our service. So we write tests for the functionality, for the functions, for the module, and really low level. And after we write the first test, we do some coding, do the normal cycle. The test fails for sure in the beginning. Then we implement the behavior, run the test again, write another test for another functionality, implement some more code even, and when we're done with the loop, then we probably have the whole functionality of one service. That's supposed to be the case, and then we're happy and can go back to the integration tests. We are probably not confident enough to say, okay, we covered everything with our integration tests, so then we do functional tests. Then we test the behavior inside of a service to make sure that everything we are not really able to verify with our integration tests could be verified with functional tests. That's more a contrary way to test if you look at traditional test-driven development, but it worked for us very well. We have the feeling that it's really efficient to us, so that's why we keep writing functional tests more on our way back. And then we go over to the integration tests and continue with our loop, do the integration test for another service. And when we're done with that, when we're happy with that, then we go, then we go back to the acceptance test. If we do this loop over and over and over, we probably reach a point where we don't even have to write so much tests or so much codes, because there is a huge intersection between the tests. If you have a typical story, then you have normally, in our case, at least 5 scenarios. So we try to cover all the possibilities, all the cases, and if you have more services involved, the test case and the possibilities get even more complex. So this increases the level of test cases tremendously. But that sounds horrible, but it's not, because we can relate to the test. Nowadays, when we do this, it's pretty fast, because we can just write down the gherkin, then we can relate to existing integration tests, which we can kind of modify. We don't have to reinvent the wheel the whole time, and we don't have to implement complete unit tests, because we're just adding functionality. So what we try to achieve with these kind of tests is a good test coverage, so that we can really make sure that we covered everything, that we are tested everything, and we want to do almost 100% coverage with our unit tests. It works pretty well. That's the easiest way to do a good coverage, because you have 100% control, and so you can really dig into the code, you can really control your code base, but it gets more trickier if we look at integration tests. 100% for integration tests, that would be great. We are not able to do that. What we do is we see the function tests I already mentioned, add optional tests. So when we don't know how to test something, then we use the functional tests. So the sum of these two is supposed to be close to 100%. And with acceptance tests, it can be just the average, what we are able to test with our integration tests. You can't test more with acceptance tests than you can test with the integration tests. We've learned a lot with this way of testing. What we've learned in the first place is that it worked for us. I'm not quite sure if this methodology worked for everyone, but we had less test code. That was pretty cool, because we had a huge amount of code that we were able to reuse. We have a huge test library. We have less fragile tests, which is pretty cool, and we have still a high test coverage. The quality of our stories increased, because the product owner has to rethink twice. It's not just I can write down a story and then it's done. He has to really think about the use cases, because he put him in a situation that he really has to write scenarios. And it was a little bit of training, but it worked out pretty well. Nevertheless, it's probably a tough start. Right now we're at the point where we have great test libraries, and every service provides its own stub, which is pretty essential from my point of view. So efficiency comes with the right tools. But we still have to deal with the deterministic scenarios, and having deterministic scenarios in Microservice environments is still a problem and still hard to deal with that. I think we reached a good point with our test libraries, but it's still our sticking point. Asynchronous is also something we are dealing with, but I'm pretty happy that we are doing the functional tests. That's kind of our plan B, and makes it way easier to do this gray and white box testing to make sure that we test everything. So use it, happy testing. and if you're stoked by the stuff we are doing. So that's it. Thank you.